Chapter 5, Section 2, Bisectors of Triangles. A perpendicular bisector of a triangle is a line, ray, or segment that is the perpendicular bisector to one of the sides of the triangle. So technically, because a triangle has three sides, there can be three perpendicular bisectors of one triangle. When three or more lines intersect at the same point, they are called concurrent lines. The point of intersection of the lines is called the point of concurrency. So if we just talked about the fact that there can be three perpendicular bisectors of one triangle, when all three of those perpendicular bisectors meet, they are going to be concurrent, which means that they are going to meet at one point, all three lines. When three perpendicular bisectors of a triangle are concurrent, so when the three perpendicular bisectors of a triangle meet at one point, the point of concurrency can be inside, on, or outside of the triangle. In your book on page 272, at the bottom of the page, there are examples of each one of these. Your point of concurrency of the three perpendicular bisectors is going to be inside of the triangle when you have an acute triangle. The point of concurrency for the three perpendicular bisectors will be on a triangle when you have a right triangle. And then the three perpendicular bisectors' point of concurrency will be outside of the triangle when you have an obtuse triangle. And that will always be the case. So inside when it's acute, on the triangle when it's a right triangle, and outside the right triangle when it's an obtuse triangle. The point of concurrency of the perpendicular bisectors of a triangle are called the circumcenter of the triangle. So the point of concurrency is called the circumcenter for perpendicular bisectors. The concurrency of perpendicular bisectors of a triangle says that the perpendicular bisectors of a triangle intersect at a point that is equidistant from the vertices of a triangle. So when you are bisecting the sides, when you have perpendicular bisectors, the point of concurrency, or the circumcenter of the perpendicular bisectors, is going to be equidistant from the vertices. This example says 3 people need to decide on a location to hold a monthly meeting. They will all be coming from different places in the city, and they want to make the meeting location the same distance from each person. If you look at the diagram they've given us, A, B, and C are indicating a location for each person. Then it asks, why would using the circumcenter as the location for the meeting be the most fair location? Remember, we just said that the circumcenter is where the perpendicular bisectors of a triangle meet. We also just said that the circumcenter is equidistant from the vertices. If you look at the diagram, A, B, and C are all vertices of this triangle. So the circumcenter would be the most fair meeting location because it is equidistant from all the vertices of the triangle, or from all the people at points A, B, and C. The next example says, which point is the best spot for placing a sprinkler to water the plants located at point X, Y, and Z? If you look at this diagram, we have point A, point B, and point C. Remember that we just said that the circumcenter is equidistant from the vertices, which again, if you look at X, Y, and Z, those would be the vertices of the plant's location. We also just said that on the bottom of page 272, it said that when we had a right triangle, the circumcenter was on the triangle, and it's on the triangle on the hypotenuse. So in this case, the circumcenter would be point C, which means point C is equidistant from all three vertices. So my best choice would be point C. B says if the sprinkler covers a rectangular region with a circular region, with a radius of 15 inches, will the water reach all three plants? Notice that they've given you the distance from the vertices Z to the circumcenter C. The distance from Z to C is 10 inches. So if we have a sprinkler that's going to cover a circular region with a radius of 15 inches, it's going to hit everything within that circle. So the answer would be yes, because all of the plants are 10 inches away from point C. The next example says the three angle bisectors of a triangle's point of concurrency is called the incenter of the triangle. If you notice, in is in the name of this. It is always going to be on the inside of the triangle. So just like we could have three perpendicular bisectors, we're going to be able to have three angle bisectors. Again, they are going to be concurrent, which means they're going to meet at one point. But in this case, they are always going to meet, the point of concurrency will always be inside of the triangle. And that point is called the incenter. Concurrency of angle bisectors of a triangle. It says the angle bisectors of a triangle intersect at a point that is equidistant from the sides of a triangle. So if you think about it, the angle bisectors point of concurrency is going to be equidistant from the sides, and the sides perpendicular bisectors point of concurrency is going to be equidistant from the angles. So they're equidistant from the opposite of what they're bisecting. If they're bisecting angles, they're equidistant from the sides. If they're bisecting sides, they're equidistant from the angles. This example says the angle bisectors of triangle XYZ meet at point P. What segments are congruent? If the angle bisectors are meeting at point P, that means that point P is equidistant from the sides of the triangle. Remember, in the last lesson we said that to measure a distance from a point to a segment, we had to be forming a right angle at the segment. The three lines that are showing the distance from point P to the sides of my triangle are PT is congruent to PU, which is congruent to PV. So my three congruent segments would be the distance from point P to the sides. It then asks us to find PT and PV. Well, notice we just said that PT and PV are congruent, so if we can find one of them, then we can find both. They're going to be the same. We are not given the length of any of the distances from a side to point P. However, if you look at the upper right-hand corner at triangle TPY, it is a right triangle with one leg that measures 12 and a hypotenuse that measures 13. So we are going to be able to use the Pythagorean theorem to find the length of TP. To use the Pythagorean theorem, we need to say that 12 squared plus x squared equals 13 squared. When you solve the Pythagorean theorem, you find that TP equals 5, or PT equals 5. If PT equals 5, then PV is also going to equal 5. And just a side note, it didn't ask us to find it, but if both of those equal 5, then PU also equals 5. The angle bisectors of triangle ABC meet at point L. Find AL and FL. Again, we have angle bisectors. In this case, they're meeting at point L. If the angle bisectors are meeting at point L, that means point L is equidistant from the sides of the triangle. It asked me to find AL. Notice AL is the distance from an angle to point L, so it does not have to be congruent to any other segment. It also asked me to find FL. If you notice, segment FL is measuring the distance from point L, or the incenter, to the side of my triangle. So FL will be congruent to, in this case, it's LE and LD. They asked me to find AL first. If you notice again, we're not given AL, so we're going to have to find it. And again, we're going to be able to use the Pythagorean theorem to find the length. because we're given the two legs of the right triangle formed, triangle ALD, are 8 and 6. So we can say 8 squared plus 6 squared equals AL squared. Well, 8 squared and 6 squared would be 64 plus 36 equals AL squared. 64 plus 36 is 100 equals AL squared. Remember, to get rid of squaring, we have to take the square root of both sides. And when we do that, we find that AL equals 10. Remember, point L is the incenter where the angle bisectors meet. So the distance from the angle to the incenters does not have to be congruent to anything. But remember that L has to be congruent, the distance has to be congruent from point L to the three sides of my triangle. So when we're asked next to find FL, notice we're already given that LD is 6, and LD is the distance from the incenter to the side of my triangle. So if LD is 6, then FL also has to be 6. Today's assignment is on page 275. It's numbers 10 through 19 all.